Hello, today we'll be introducing you to our project, BERT-based reverse dictionary by Alex, Jinshi, Kai, and Arden. So in conventional dictionaries, we are usually given a word as input and a phrase describing the definition of such word would be outputted. For example, if we have a happy as our vocabulary, we'll be given, say, feeling or showing pleasure or contentment. So this is the normal procedure for a dictionary. However, what if we want to find a word based on a given phrase as input? In this case, we have the reverse dictionary where that takes in phrase and outputs a word based on that definition of such phrase. However, reverse dictionaries require substantial development as it is not a mature, there's no mature reverse dictionary yet. The significance of the reverse dictionary is twofold. First, it can solve the tip of tongue problem where speakers of a language cannot think of the specific word they have, even though they seem to have an idea of it. The second is that reverse dictionaries can help expand language learners' vocabulary. In order to build a reverse dictionary, we use the following methods.
So our data set is the WordNet-based data set, which includes approximately 750,000 word definition pairs and 50,000 unique words. We measure our model's performance on 3 distinct test sets: a seen set consisting of 500 previously seen words, an unseen set consisting of 500 unseen words and their definitions, and a description set of 200 human-created descriptions of seen words. Our evaluation metric uses the 1-10-100 metric, where we look at the proportion of test cases where the target word appears in the top 1, top 10, and top 100 output words.
We take as our baselines OneLook and WantWords. OneLook is a conventional information retrieval approach, which searches index dictionaries for the input description. WantWords is a BERT-based approach, which uses contextual embeddings from BERT, as well as additional lexical information to generate predictions. Our first approach is based around re-implementing a 2020 paper, BERT for Reverse Dictionary. We name this approach BERT M-Mask Language Model, or MLM, as it involves injecting M-mask tokens at the start of the sequence and learning to fill them in with the subwords of a target word. This is important because BERT operates using BP tokenization, which breaks words down into parts. We also make slight modifications to the training and procedure presented in the previous slide, in which we teach the model to learn not just the subwords of the target word itself, but also to learn its synonyms and other related forms. For example, the word the definition of the opposite of happiness could be targeted to the word sadness. However, we might also map it to depression, gloominess, unhappiness, and melancholy as well. This gives the model more lexical knowledge, which yields stronger results. We also try applying variants of BERT to the task. Our first candidate is sentence BERT, which is a variant that is trained to produce semantically meaningful embeddings at a sentence level. Thus, we simply pass the sentence embedding through MLP and obtain predictions over the whole vocabulary. Our other candidate is character BERT, which is a character and word level approach. We use a similar approach to the masking model, where we inject one mask token at the very start, and we use that one mask token to create predictions for a whole vocabulary. Overall, we find that our BERT-based models perform very, very strongly. In particular, our multi-label BERT model produces strong results on unseen data, which speaks to the helpfulness of adding additional lexical data for training. However, it does perform worse on other sets, likely because it trades precision for recall ability. Our BERT MLM model also performs strongly. It is competitive with OneLook on seen data and performs strongly on human descriptions as well, which means that the mass training objective is a strong approach. Our sentence BERT and character BERT models perform less well. They seem to overfit heavily to the data, which we suspect may be due to the limited capacity of the output MLPs. This has been our reverse dictionary project. Thank you for watching.